Hello, my little mathematicians. Today, we're going to help you figure out how a rate can be represented in both a graph, an equation, and a table. Okay, so first off, rates can be displayed on this is a coordinate plane, right? Just like ratios can. Okay, so the first thing is let's go ahead and fill out this table for Michael. Okay. Well, if they want it as ordered pairs, that's where you have x comma y, or you can also think of it as, like a table where it's x and y. Okay. Either way you want to think of it. So first off, which line is representing Michael over here? Well, he's the solid line. So he's this line right here. So where are the points that you see on this graph? I see this point right here at the origin of 0, 0. The next point for Michael I see went over 1 and up 8. And then do you see any other points? I see a point right here. That went over 2 and up 16. Okay, so I filled out the table, or I created ordered pairs for Michael. Now let's see if we can complete the table for Olivia. Okay, Olivia is represented by the dotted or dashed line. So this guy. What's the first point you see on that line? Right here at the origin. What's the next point you see? What's that one? Well, it went over 2 and up 6. Do you see another point? Yeah, right there. So that one went over 4 and up 12. Okay, so the next thing they want us to figure out is what's Michael's rate and what's Olivia's rate. So since I'm holding the pink pen, let's look at Olivia's. What are you doing each time to the x to get to the y? If you said that you were multiplying by 3, let's see if that holds up. 4 times 3 is 12, 2 times 3 is 6, and 0 times 3 is 0. So, okay, I believe you. The rate would be 3 miles per hour. And you're like, wait, how do you know the units? Okay, well, remember the rate is y per x, right? And y is talking about the miles, and x is talking about the number of hours. So 3 is the number that remains constant that you're multiplying by each time, and then the units are the y per x, so miles per hour. Let's use that same logic to figure out the rate for Michael. What are you multiplying by each time? If you said 8, let's see if that holds up. It does, because 0 times 8 is 0, 1 times 8 is 8, and 2 times 8 is 16. So that means that the constant is 8, and my units would be, again, miles per hour. Okay, so the unit rate, they're going to be asking us, that just means when the denominator is 1, okay? So for the denominator to be 1, okay, remember it's y per x, and then the unit rate is when the denominator is 1. So what value is 1, the x or the y? Yeah, the x value needs to be 1. So in your coordinate point, okay, x is 1, and then like the unit rate is going to be whatever the numerator is, which is the y value. So if you were to find when x is 1, what's y? That would be your unit rate, okay? So for Michael, that one's pretty easy, right? Okay, Michael's is what? Yeah, 8x. And you're like, okay, I could figure that out here. When x is 1, y is 8. Or I could have seen right here, 8 miles per 1 hour. Oh, yeah. Okay, this is normally how they're going to write the equation. They'll say write y in terms of x. Or if they say use h for hours and m for miles, well, then which one do I put where? Well, y is talking about the miles and x is talking about the hours. Okay, so your equation depends upon how they ask you to define your variables, but it's still saying the same thing. Your independent variables be multiplied by the constant rate, and that's set equal to your dependent variable. Okay, for this one, what's the rate here? If you said 3, you're right. Okay, that's the unit rate because it's 3 miles per every 1 hour. Okay. And then again, if they said, please write y in terms of x, that would have been the equation. But if they said use m and h, this one would have been m equals 3h. Either of those are correct depending upon how they're asking you to write it. The unit rate is the value of what in an equation? Do you guys notice already? Yeah, it's the coefficient in your equation. Okay, coefficient means the number in front of your variable. So it's the coefficient. Okay, the number in front of your variable, but in this case, it's the number, your variable is always going to be your x typically, right? Okay, so the number in front of x, that's going to be your coefficient, and that's going to be your unit rate. So if I were to look up here, I kind of sort of already started this, didn't I? When I was supposed to do ordered pairs, they wanted it to look like 0, 0 and 1, 8 and 2, 16. Those are really the ordered pairs, but I just kind of already made it into a table. So here's what they were looking for. The ordered pairs should have been there in those boxes. And then that represents when x is 0, y is 0. When x is 1, y is 8. When x is 2, y is 16. So if x is 3, what would you get? Yeah, 3 times 8 is 24. Well, what about when it's 4? Hopefully you said 32. Because again, what are you doing each time? You're taking the x and you're multiplying it by 8 to get your y. Okay, here, again, they wanted the ordered pairs technically in these boxes. It should have been like this. Okay, and then you just need to know that an ordered pair, if you were to fill it out in a table, when x is 0, y is 0. When x is 2, y is 6. And when x is 4, y is 12. Okay, so if I were to keep going with that, let's see, I'm going 0, 2, 4, 6, 8. Okay, what are you doing each time to the x's to get the y's? Yeah, you're multiplying by 3. So 6 times 3 would be 18. And 8 times 3 would be, you got it, 24. So the unit rate is the y value when the x value is what? That's right, 1. Okay, so in a table, if you were to see when the x value is 1, that's going to give you what the unit rate is. Or, of course, you could look in the equation, like figure out the equation, and then it's going to be the coefficient in your equation. All right. Hopefully that made a little bit of sense. Let's practice some harder ones. Okay, if we turn the page. This time they're going to give us tables, and from those tables, we're going to have to try to figure out the unit rate. Okay, so what are you doing each time to the x to get that y? You're multiplying by 4,000, right? Or like you didn't even really have to do that because didn't we say the unit rate is whatever, when the x value is 1, it's the y value. So it's 4,000 steps per 1 day. And there you go. Okay, so that would be the unit rate for this table. Did they give me when x is 1? No. When x is 1? No. When x is 1? No, sadly. Okay, so then what I could do is two different things. Okay, I could figure out what am I multiplying by each time? Okay, 2 times what is 5,000? Well, if you said 2,500, that's right, because test that. Do 4 times 2,500, you'll get 10,000. Do 6 times 2,500, you'll get 15,000. So then my rate, remember, my equation would be y equals 2,500 times x. And whatever your coefficient is, that's what your rate is. It's 2,500 steps per every 1 day. Technically, another way you could have done this is you could have picked any of these points. I'm just going to pick this one because it looks easy. Okay, if you had 10,000 steps every 4 days, right? Because you want the x to be in the denominator, y per x. So for this point right here, How would you get 4 to become 1? That's right, you divide by 4. So then do the same thing on top. And if you did 10,000 divided by 4, you'd get this. So technically you could write one of your points as a ratio and then find the unit rate that way by making the denominator become 1. Okay, so again, what if I were to pick this point? Y per x, okay, and I want that denominator to become 1, so what would I have to divide it by? Itself. And then whatever you do in the denominator, do in the numerator. Well, what's 12,000 divided by 4? Oh, and it wasn't 12,000, sorry, it was 12,800. What's 12,800 divided by 4? It's 3,200, okay? So it's 3,200 steps per day. That would be your unit rate. Now, if you test that, multiply 4 times 3,200. Does that equal this? Yes, it does. Try 6 times 3,200. Does it equal 19,200? Okay, perfect. Then that's our pattern. Okay, if you haven't tried any yourself yet, pause it and try number 4. Okay, now that you unpaused it and you're back with us, let's see how you did. You could have figured out like 3 times what is 4,200, or you could have done 4,200 over 3, remember y per x. And how would I get that to become 1? I would divide the denominator by itself and then do the same thing on top. And 4,200 divided by 3 is 1,400. Okay, double check. If you were to multiply 3 times 1,400, do you get this? Okay, test it again. 5 times 1,400, does that give you this y? Okay, perfect. That's how you go about finding the unit rate from a table. Okay, the easiest way is when the x value is 1, there you go, that's your unit rate. Or you could just pick one of the points and then find the unit rate, by dividing it by the denominator. Or you can just do what we've done before and try to figure out the pattern from the table. And then that gives you your rate. Okay, the easiest thing is when they say, please find the unit rate from the equation below. Done. It's the coefficient, so that one's 2.50 or 2.5. This one would be 18. Yes, it is that simple. What's this one? Hopefully you said 1/2. What about this one? Hopefully you said 1.75. Okay. Last thing. They want us to sketch a graph from these unit rates. Okay. So what I need to do is I need to first create a little table to be able to plot some points. So if I plug in, let's say 0, 1, 2, and 3, what would my y values be? Well, my unit rate is 6. So that means that's what I'm multiplying by each time, right? So what's 0 times 6? 0. What's 1 times 6? 6. And 2 times 6? 12. And 3 times 6? 18. So my x values, I could probably count by ones. I could even count by ones like skipping every other one, right? Okay. So whether you counted each line by 1 or you like technically counted by halves, okay, as long as you remain consistent, you're good. Now, if I did that for this, I'm never going to be able to graph them all. A smart thing to count by, maybe 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and that way I got all my points accounted for. And then I just plot 0, 0. Then over 1 up 6. Over 2 up 12. And finally, over 3 up 18. Now, always double check that when you connect those points, it makes a perfectly straight line. If you go to connect those points, and let's say like one is way over here, and you have to go off the line to get to it, alarm bell should go off. Something's wrong, okay? Because these all make perfect linear equations because it's moving up and over at a constant rate. Okay. If you haven't tried these yet on your own, go ahead and pause it and try them, and then unpause it and come back. Okay, so you tried them, you unpaused it, you're back with us. Let's plug in again, like 0, 1, 2, 3 is going to be annoying. Let's plug in 4. Okay, So 0 times 2.5 is 0. 1 times 2.5 is 2.5. 2.5 doubled is 5. And then let's type in 4 times 2.5. You get 10. Okay. So here I can kind of count the same way I did before. 0, 1, 2, 3, 4, and 5. Okay. And then for this one, I can probably just count by ones because the highest I have to go up to is 10. And we know if we count by twos, we go up to 20. So it'll fit just perfectly with 10 at the top. Okay. Now I plot my points. Over nothing, up nothing. Over 1, up 2.5. Over 2, oops, and I just messed up, didn't I? I was supposed to go here. This is where I labeled it. So that is not actually one of the points. Over 2, up 5. And over 4, up 10. Now double check, are those in a straight line? Yes, they are. And then see, like, if I try to do that, it would have been curved. And so I would have found my mistake that I did something wrong because they all should be in a perfectly straight line. Now, if you did yours where you just counted like every line 0, 1, 2, 3, 4, 5, it's fine. Okay, as long as you remain consistent on that axis, it's all good. Last problem. Okay, let's plug in 0, 1, 2, 3. And 0 times 15, 0. 1 times 15, 15. 2 times 15, 30. 3 times 15, 45. Okay, I can count the same for the x. I'm going to put little dashes so I don't mess up again. If you find yourself messing up, that might help you. Okay, now if I count by ones, no. Even if I count by twos, no. Let's try maybe by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That worked perfectly. Now, if for some reason not all of your points are on the graph, as long as you have at least 2 points on the graph, you're okay. But this one, we were able to fit all of them. So over nothing, up nothing. Over 1, up 15. Over 2, up to the 30. And over 3, up to the 45. And there we go. Another perfectly straight line. Why? Because these are linear equations that move at a constant rate, which means they go up and over the same amount each time. Okay, my little mathematicians, good job. You got this. You are now masters at finding rates from equations, tables, and graphs.